Example 3. Celeste drew an outline of a building for a diagram she was making and then drew a second one mimicking her original drawing. State the coordinates of the vertices and fill in the table. When we talk about vertices, we're talking about the corners or points on our shape. So the first thing I'm going to do is go through and I'm just going to list my point coordinates out. So this first one I would go over 7. And then I don't go up any, so it'd be 7, 0. Let's see if we can zoom in a little bit. Okay. I would go over, see there's 10, 11, 12, 13. And again, I don't go up anywhere, so it'd be 0. For this point, again, I go over 7. And then I go up, there's 15, 16, 17, 18. And then for this point, I go over 13 and up 18. On my image, I go over 7 and up 0. On this point, I go over to 10 and then up 0. For this point, I go over 7 and up 9. And then for this one, I go over 10 and up 9. All right, so I'm going to zoom out so we can fill in our table. All right, so we're talking about the height of this original drawing. So if I know I'm at 0 and I go up to 18, that has a height of 18. And then a length, so from 7 to 13, that would be 6. In my scale drawing, I'm at 0 and I go up to 9. And I'm at 7 and I go over to 10, so it'd be a distance of 3. All right, now we're going to use this information to answer some questions. Is the second image a reduction or an enlargement of the first, and how do you know? So if we go back and look at our picture, is this a reduction or an enlargement? So since this gets smaller, this would be a reduction. It is a reduction because it gets smaller. Okay. Our next question. What do you notice about the information on the table? So we're going to go and look at our numbers that we have in the table, and let's list some things that we notice about our numbers. The scale drawing has smaller numbers is one thing I notice. So scale drawing has smaller numbers or links. I also notice that these are half as big as these. So the scale links are half as big. Okay. Does a constant of proportionality exist, and how do you know? So if we go back to our table, let's think about what we learned about constant of proportionality. This is where we're starting, so here's our x, and here's where we're ending, so here's our y. So we're going to divide our y by x, or divide our x by y. So do y divided by x, and let's see if we get the same number. So we're going to do 9 over 18, which those are both divisible by 9, so that simplifies down to 1/2. And then my other side was 3 to 6, which again, both of these are divisible by 3, so that simplifies down to 1/2. So yes, they both have a k value of 1/2. Our next one, what is the constant of proportionality and why is it important in scale drawings? So we've already found in our last question that our constant of proportionality was 1/2. Sorry, our k value, which is our constant of proportionality is 1/2. If we don't have that constant of proportionality for all of the sides, then the image isn't proportional, so it wouldn't look the same. So if it didn't exist, then the image would not be proportional. And the images wouldn't look the same. One would be longer and make it tall or short or something like that.